Hi and welcome to the second episode of my activity tracker app series. This is a series when I build an app with .NET MAUI and Blazor, a hybrid app. And if you haven't watched the first one, I recommend you to go and watch that one first. So this is the second, and today we'll continue with saving data and writing some unit tests for that. We will use a non-SQL database called DBLite that I really like, and I also use it in some of my own apps. So I should not stand here just talking. Let's go and open Visual Studio and continue to build the app. If you like this app, like and subscribe, and let's go code. So here we have Visual Studio, where we left last time. If you want access to this code, you should go and become a gold member. Then you will get access to all the code that I write for my YouTube channel. Here we have the app. We have a MAUI app project. We have a shared project and we have a component library. Today we will spend the most of our time in this shared project, and we will start to create a service layer or a data access layer, but I will call it services because it will not just be data access. We go and create a new class, or we will start with an interface. So we will call it iActivity service, and for that interface we will have a couple of method: start, pause, resume, stop, and log. So we should also go and fix this because I prefer to have the namespace declaration like that. And now we will need to create this model. So we go here and we create a models folder. Models, and of course you should have services folder also. So we do that. Services. Then we move the interface to the services folder. And the namespace is fixed for us. So now we go and create this model. Add new class, current activity summary, and it should look like this. We have a double distance property. We have a constructor that takes a distance and a duration property. And we can make the properties together like that because that is nicer, I think, and we can remove and sort the usings, because I don't like to have more using that I'm actually using. So now we have the interface, then we can go and create the implementation. So we create a new class, we call it activity service, and we implement iActivity service interface, just like that. And now we have all the methods there with, and they're throwing a not implemented exception, but we will soon fix that. So the data that we will save will be in a database when we run it inside of the app. Maybe we will write some sync to a server later, so we can access that from the web. Because as I said in the first episode, the idea is that this should be both a website and an app, but it should not have all the functionality in both. For example, track an activity. You don't do that on a website, but you do that on an app. But maybe you can register an activity and read-register your data on a web app too. So we go and add the LiteDB NuGet package. A LiteDB is a C# non-SQL database, a document database. And I have a video about that if you want to know more about LiteDB that you can go and check out. So we go to browse and then we search for LiteDB. So, and then it shows up, and then we install it. Some of the code that we will have for LiteDB will be shared between multiple services, and for that I will create a service base class that services that use LiteDB can use. So right now we call it just service base, but if we have more types of service base, we maybe need to name it like local database service base or local service base or something. I don't know. But right now I just have a service base. Public abstract class service base. And it should be disposable. so we can close the connection to the database when we are done. Implement that interface and have the public dispose method. So now I will write the code testable. That means that I want to be able to write unit tests. And when I do that, I want to save the database on one place, and on the app I want to have it in a specific folder for the app. Because LiteDB is just a file. You specify it and you write it to disk. So for that I will create the I file system helper interface that I can use different implementations for. So I can have one implementation for the test, I can have one for the app, and if I need to, I can have one for the web page also. But that is probably not relevant if you do a WebAssembly app, for example. But if you do a Blazor server app, you maybe want to access the file system. But I don't know. Right now I have it to be able to have different for test and app. So we go here and we create a helpers folder where we can put all the helpers. Then I create the interface. I file system helper. And right now it will only have one method called get app data directory. So, and for the app, we will create an implementation and we'll put that one in the app project. So create a helpers folder here too. And then we'll create an implementation. And we can call that one app file system helper. Public class app file system here. And we add the I file system helper interface. We need the class keyword here, of course, like that. We have the interface and we'll do the implementation. And here we can use what's inside MAUI because they have a great file system helper too, but we cannot use that for the tests. And that is the reason that I do like this: file system dot app data directory. And here you can see we could have used the cache directory also if we don't want the data to be in backups, for example. But in this case we want to have it here because this is not cache data. So just like that. Maybe you could have used this I file system interface too and create an implementation, but I like to have my own here. So now we have that one. We can go back to the service class, the service base, and then we can do like this. We create a constructor and then we say public service base and I file system helper, just like this, and create an assign field file system helper, and that one can be read only, just like that. Now we will create our first method here, and that is will be get database, and that will get the database object to be able, so we can use that in the activity service. So private light database, that is the object that you will return. So call that get database, just like that. And now, and if we have multiple places calling this get database, it should wait, so it will not create multiple of them, because then we will have reading conflicts on the file system. So we will here add an semaphore slim, and this one should also be async. So we do async task like database, and then we create a semaphore slim, a static field. So it will only have one instance of this, and we can see here that we have an initial count and a max count, and that means that only one can access this code. So we say await semaphore slim dot wait async. Now the execution will wait here until the semaphore slim is released, and we do that by say semaphore slim dot release, and that means that the next thread, for example, can access this code. We both create a field and a property. The property should be static here, so we only can use it once. So we add it here at the top. We have a static light database that can be nullable, and then we have the property here, and that means that this cannot be async. So we change back to just return light database, and then we use wait instead. No await there. So, and then we will have a warning. That means that Semaphore Slim is not supported on browsers, but that is fine. This will not be used on browsers. This will be only for the app. And then we can check if database is null. And this also means that if the database has been created, when the other thread is waiting here, it can just return this object instead of creating a new one. Here we just return database like that, but here inside of the if we will create the database object, and for that we specify a path based on the file system helper. So path is path.combine, file system helper get app data directory and the name of the file. And here you can name it whatever you want. I prefer to have .db in as a file ending, because that is what it is. It's a database. So database is new light database and path, and add the path to it. So now we have a method creating the database, and then we can create a method for delete the database. This will mostly be used by the test, and that means that we can have a new database for every test. But of course that can be used in the app also if you want to remove the data from the app. So protect the delete database. We use the Semaphore Slim again, so it will be just only one thread that's trying to either create the database or delete the database. And then we have the dispose method, and then we check if database is not null. Just doing that, dispose, because this database is a nullable object. Dispose that, and then we set database is null, just like that. And probably we should also set the database is null in this method here. No, we don't need to do that because we need to dispose the database before we can do and delete. Okay, now we have this base class. We can go and continue to write the actual service, the activity service. So we do that. We have start, stop, and pause and resume. In this episode, we'll focus on start. Then we need a document or an entity that we can save into the database. So we'll go and create an entity too. So create a new folder for that. Add folder, entities, and we create an activity entity. Activity. And I guess you don't want to watch me type this, so I will just copy that one in already because I prepared a bit before. And here we have an activity with ID, type of activity ID, events and locations, distance, duration, and a comment. And the activity event is a different type. It can be start, pause, resume, and stop right now. And then we'll have a timestamp for that. And then we'll have location with latitude and longitude and time when the user was on that location. So now we can go back to the service and we go to the start method. And then we do like this. We go and get the collection. Var collection is database from the base class. But if you want to use the base class, we of course need to add that one too. Service base. And this should be public. And now you can see that we need to pass the file system helper to the base class too. So we do that by creating a constructor, public activity service, I file system helper, and pass it to the base class. And then we don't need to do anything else with it right now. So now we can continue here, database dot get collection, and have activity as the generic argument, just like this. And then we do var activity is new activity. So, and then we need an ID, and we set that ourselves, guid.new guid.toString, because this is a string ID, but I like to have it as guids anyway. So, and then we also need type of activity ID, just pass that one, and later we can make it possible for users to add their own type of activity and we can predefine them. But we will not do that right now. And then we will have events, because now we will have the start event inside of here. So we do like this, new, and we pass the first event, and we have time, date time.now, and type of event is activity type.start, just like that. And now we can do collection.insert and insert the activity object. We return the ID of the activity. And that is the reason why I created this as a variable and not created it directly inside of here. But as you can see, this is a task, and that means that we need to return it as a task as well. But right now we don't have any async stuff in here, so we will do task.from result string. But I prefer to have this as async method anyway, like that. Okay, we don't need to define the string there because it will know that anyway. So, and then we're done with saving the data, but we will also have two other fields, one for distance and that for duration, because we want to update that live when the user tracking an activity, because if they have the app open on the screen, they will see that in real time, the new distance, the new duration. So we'll create two fields for that we will use when we have an active activity. So we add them at the top, that, and to be sure that they are 0, we set that here as well. That this is also the default values for double and time span, but if we have had another activity running, we want to reset them. So that is the start method. Now we can go and create a unit test for that to verify that this works. If we had worked with test-driven design, we'll probably created the unit test first, but I mean, you do what you like. I prefer to write the test at the same time as I write the code, not before. But of course, sometimes that is the best approach also. If I have a bug, for example, in my code, I like to first create a failing test that helps me find the bug, and then I can use that test and debug that test to try to find a fix. So now we will go and create a test project. We do that by going to add new project. And for this, I will use XUnit because that is the one I have used most recently, but I think XUnit and unit, it doesn't matter. It's your personal choice. They are pretty similar. Activity tracker app.tests. So when we create a new test project, we'll get one unit test, and it's called unit test 1. So you can either delete it and create a new one, or you can rename it. I prefer to rename it. So activity service tests, and then we do like this. Rename to that, and we can rename the file too, so they are the same. And then we rename this to start activity test. And it should also be async and return a task. And now we also can have an implementation of the async lifetime interface, because that makes it possible to run code before and after each test. So before, we don't need to run anything right now, so we just return task.complete the task. But in the dispose async method, we should remove the database, so we will have a fresh database next time we start with a test. So we do that by doing this. And here you can see we need a test file system helper, so we'll go and create that one too. And then we do add class test file system helper, and that will also be a simple one. We just use this path.get directory name and put it in the assembly folder. And here you can see we need also to add references to this shared project, of course. So we do that just like that. And then we include the namespace and everything will be fine here. So now we can go back to the test and we should add a field at the top of the test. That is file system helper. And then we can create a new one in the constructor. Public activity service tests. And here we just new it up. File system helper is new test file system helper. Okay, so now we can use it like that. Great. And now we can go here to the actual test method. And the first thing we should do here is to create a new activity service. So we do that by saying var service is new activity service. And now we just pass the file system helper. We don't need to set up an IOC container or dependency injection or whatever you want to call it for that. And then we call the run method. Await service dot start. And then we need a type of activity ID, and here we can just say something, so we say run. Just like that. And now we can assert that we get an ID back. And here I like a package called fluent assertion, because that makes the assertion pretty fluent and nice. So we're going to install that package as well. Fluent assertion install. And now when we have that one installed, we can go add a using for it. Using fluent assertions, just like that. And then we go back here and say id.should. And then not be null, not be null or empty, or null or white space. Let's go with null or white space in this case. So then we do service.dispose to release the database file, so it can be deleted, and so that we can check if we have something in the database, because I don't want to use the activity code for that. I want to write that code in the test, so we can be sure, so we can control all the code in the test. So for that I create a new method called getActivity that we put in the end of the file, just like this, and also need a using here for entities. And then I get the path, I create a new database object, and I get activity, and I dispose the database again. It's really important to dispose the database object, otherwise we cannot access it again. Then we will have a concurrency error. So now when we have that, we can go back to our test, and now we can get the activity by put it in a variable, get activity, pass the ID, and now we can, for example, check here that we have only one events added. So that should have count 1. So now we can run the test and see if our code works so far. So run tests. Yeah, the tests succeed, and that seems like our code works. At least we know that it works a bit better, and we can also use those tests if we want to refactoring to make sure that the code's still working. So let's continue with the log method. And now we can start by creating a test for that. So we create a new test. We add the fact attribute that tells that this is a test, public, async task log activity test. And now we should start the test by adding some data to the database, because when we log data, we want to make sure that we have a state where the activity is created. So we also go and create a new method here that is add activity that we can use for other tests as well also. That's the reason I prefer to create those helper methods outside of the tests, so we can reuse them in multiple tests. So add activity. Here we have more or less the same as in the service, but in a controlled environment. So if we want to change the test, we can do it without changing the service. So we create a new activity here with an ID, we have a start time, we have an event that is the start event, and we have a first location, the location for when it starts. So this will be the second time we call log. It will simulate that in the test. And then we should create the service, and we call the log method and pass the ID, the coordinates, and a new timestamp. So this is 5 seconds later than the start time. And when we have the result, we can go here. We can go and do some assertion for that. So then we say result dot duration dot seconds dot should be 5. And then we can do the same for distance. So math.round, because we need to round this a bit because we only wanted to have it on meter precision. And for this I used a service on internet that calculated distance. So we can have that as a baseline and verify that our code will be the same result. So math.round result.distance, and we will have 3 decimals because this is in kilometers, and we want to have, as I said, on meter precision. So it should be 0.067, just like that. And we of course also need a should here. So now the tests are ready, and now we can go and create the actual implementation until we have a test that succeeds here. And now of course it fails, but that's a good start. Now we have a test that we can use to debug our code as well. We don't need to create a whole app just to make this code, and that's a good thing. And that will make the development loop faster also. You don't have to restart the app every time you have made a change to the log activity. You don't need to go out and run. You can just use the test for the debugging. So we go to the log method here that return a current activity summary. So the first thing we will do in that method is of course to fetch the activity. And we do that by getting the collection first, then we get the activity. So we say collection dot query, because we want to use link here. Then we always need a query. So where x.id is equal to activity ID. And then we say first, because we know that we have this object. So when we have that, we can go and check what the last event is. Because if last event is a pause, we should not log this event. Then you need to start it again first. But if we have some events coming in here anyway, we don't want to save it if it is paused. After that, we can create a current location object that we can save to the activity. So we say activity.locations.add current location. But now we also want to calculate the distance, we want to calculate the duration. So when we do that, we can use some of the method from the location service in MAUI. To do that, we need to go and add MAUI to this project. We do that by saying use MAUI true, and then we add the NuGet packages for MAUI. And this will work because we don't have any platform target frameworks here. We just have .NET 8. And to calculate distance, we also need the last location that we have saved. So we will add that one to a variable. Last location is activity location, last or default, but of course we need to have it before we add the new one. Otherwise, the new one will be the last. So then we can check if last location is not null, because if this is the first one we call log, we cannot calculate the distance, of course. So var new distance is equal to Microsoft.maui.devices.sensors.location. And here I just want to use this calculate distance. It's a helper method here that I think is nice. Then we say last location dot latitude, last location dot longitude, and current location dot latitude and current location dot longitude. And then we need to have a distance unit, and here we have kilometers. And now we can update the distance field. Of course, you can set that directly, but I use this as a separate variable, so it will be easier to debug. Just like that. Yeah, okay. Now we have the distance calculated, then we can go and calculate the duration. So if we only have one event, we can just take the start time and the current time, and then we have the duration. But if we have different events here, we need to calculate that a bit more. So then we create a helper method for that. And I prepared that method a bit because that is not main focus for this app, but I will explain it. So let's return time span, we pass an activity, we loop through all the events, and then we add location here. So then we add an else, and we say duration is calculate duration, and we pass the activity. And then we're done with the calculation duration. Then we just need to return the summary here. So return task.from result, new current activity summary. We pass the distance and the current duration. Just like that. Okay, now we can go and run the test to see that if this works. So open the test explorer and we run all the tests. Oh, the tests succeed. Then we have the log method ready also. And this was everything for this episode. In the next episode, we'll also add this to the app and write a UI for that, start listening for location changes. And if you want access to this source code, you can be a gold member, and all members of my channel will get early access to videos. For example, this video was released for members at the same time as the first one. And I will continue to do like that in the future. I will release 2 videos at every time for members. So like and subscribe this video, and I'll see you next time. Bye bye.